Hello students, how are you all? I hope you all are maintaining very high spirits, right? In the previous lecture, what we have discussed was regarding uniformly accelerated motion. We have discussed acceleration in detail, isn't it? So when A is positive, when A is negative, when A is equal to 0, various graphs related to position time, velocity time, right? So in this lecture, we will be basically concentrating on uniformly accelerated motion. Students, as you are aware, a body is said to possess uniformly accelerated motion if the acceleration of the body is constant. It can either have constant positive value or can have constant negative value. So, when the velocity of a body increases or decreases at a constant rate, then the body is said to have constant acceleration. It is only in this case that the body is said to possess uniformly accelerated motion. Now students, when a body possesses uniformly accelerated motion, then there are three important equations which are collectively known as equations of motion. And these equations of motion are valid when a body is in uniformly accelerated motion, right? So, in order to discuss these three equations, we first need to understand the notations which we will be using while deriving these equations, right? So, these are the notations which we will be using. U, as we are aware, it stands for the initial velocity of the body. U is the initial velocity of the body, right? V, it stands for the final velocity of the body. Look, in the case of non-uniform motion, the velocity of the body will keep on changing, isn't it? In the case of uniform motion, velocity of the body would have been constant. But here, the velocity of the body keeps on changing. It either increases at a constant rate or it decreases at a constant rate. So, U is assumed to be the initial velocity. V is assumed to be the final velocity of the body, which the body attains after time t. S is the displacement covered by the body during time t. And A is the acceleration. And since we are considering uniformly accelerated motion, therefore acceleration, it is constant. It is constant. So let's see which of these quantities are constant and which of them are variable. Constant means whose value will remain fixed even with the passage of time. Variable means whose value will keep on changing with the elapse of time or with the passage of time, right? Initial velocity, it will remain same. Initially, whatever velocity the body possesses, that is known as its initial velocity. So it will remain constant. At a given instant of time, the initial velocity of the body would be remaining same. Final velocity. Now with the passage of time, the body will either get speeded up or it will get slowed down at a constant rate. So obviously its final velocity will keep on changing with the passage of time, right? So it is a variable. It is a variable whose value is not fixed. It will keep on changing with time. Displacement, obviously it can't be fixed. The body is in motion. So the displacement of the body will also keep on changing with time. So this is also a variable. Time can't be constant, isn't it? It will keep on changing. Time will keep on elapsing, right? So out of these, only initial velocity and acceleration is constant. Rest of the three will change its value with the passage of time. So students, we will now discuss the equations of motion. As I have told you, for deriving these equations of motion, we are considering the body to be in uniformly accelerated motion. So, we are considering this case, uniformly accelerated motion, where A is constant, right? This is, student, known as the first equation of motion. This is known as the second equation of motion. And this one is known as the third equation of motion. Now look, over here, V is variable and T is variable. So it is known as velocity time relationship. It is known as velocity time relation. So first equation of motion, that is v equals to u plus at, is known as velocity time relationship. Clear? Second one, which are the two variables? Displacement and time. U and k are constants, as I have already stated. So the second equation of motion, which is s equals to ut plus half at square, it is known as displacement time relationship. It is known as displacement time relationship. Third equation of motion is 2as is equal to v square minus u square. Here the final velocity v and s displacement, they are the variables, while acceleration and initial velocity, they are constant. So it is known as displacement velocity relationship. So students, these are the three equations which are collectively known as equations of motion. Again I repeat, these are the equations which are valid when a body is moving or having uniformly accelerated motion. This is the first equation of motion. It is also known as velocity time relationship, and it is v equals to u plus at. This is the second equation of motion known as displacement time relationship. It is s equals to ut plus half at square. This one is the third equation of motion, which is the displacement velocity relationship, and it is 2as is equal to v square minus u square, right? So in this session, we are going to prove these three equations. We are supposed to mathematically verify these three equations. We will start with a normal method, right? From the point of view of junior classes. So what we do is, we are aware of these notations, right? So what we do is, by definition, we are aware acceleration, it is given by change in velocity divided by time. Students, we are aware acceleration is the time rate change in the velocity of the body. That is the change in the velocity per unit of time, that is known as acceleration. And change in any physical quantity means the difference between the final value and the initial value. Final value minus initial value. So over here, change in velocity, it would be final velocity minus initial velocity divided by the time taken by the body to change its velocity from initial to final value, right? So let's substitute the notations used. Acceleration is denoted by a, final velocity, it is v, initial velocity, it is u, and the time taken by the body to change its velocity from u to v is t. Now we can easily cross multiply it and rearrange the terms. So what we get is, after cross multiplying, we get at is equal to v minus u, or v is equal to u plus at. This is, students, the first equation of motion. And as I have told you, it is also known as velocity time relationship. It is also known as velocity time relationship. Clear? So this is a very simple verification. Only by knowing the definition of acceleration, the first equation of motion can be easily verified. So this is velocity time relationship. Now we are supposed to prove the displacement time relationship. So displacement, we are supposed to find an expression for the displacement in terms of the acceleration and time, right? So what we do is, we are aware the displacement covered by a body would be equal to its average velocity multiplied by the time. We can write it like this: displacement is velocity multiplied by time, isn't it? Now look, during the time t, the velocity of the body changes from u to v. U is the initial velocity, and after time t, the velocity of the body changes to v. So what will be the average velocity? Average means arithmetic mean, sum of the observation divided by total number of observations. So here what we do is, displacement, as I stated earlier, it was represented by capital letter S. Average velocity, that can be taken as the arithmetic mean, which is the sum of observation divided by total number of observation. Initial velocity was u, final velocity of the body is v. So average velocity can be written as v plus u divided by 2. This will give you the average velocity, which is the arithmetic mean of u and v. This is basically the arithmetic mean of u and v. Time. What is the time? It is t. Clear? Now, in order to prove this relationship, we need to eliminate v. So we can make use of the first equation of motion. From first equation of motion, v is equal to u plus at. Put this as equation A. So what to do is, we can write S is equal to, in place of v, substitute the value of u plus at. So it is u plus at plus u divided by 2 into t. So what I have done is, simply substitute the value of v from equation A. V is equal to u plus at. Now let's keep on solving it. What do we get? Like terms can be added, u plus u, that will give us 2u plus at divided by 2 into t. If you open the bracket, we get 2ut plus at square divided by 2. Students, it can further be written in this particular manner: 2ut divided by 2 plus at square divided by 2. 2 get cancelled, so we are left with S is equal to ut plus half at square. So students, this is the displacement time relationship, which is actually the second equation of motion. I hope it's pretty clear. Very simple, isn't it? Just make use of the concept of displacement as the product of average velocity and time, and make use of the result obtained in the first case, right? So that's it. This is the second equation of motion. Let's consider the third one, which is known as displacement velocity relationship. It is the relationship in displacement and velocity, right? S and V are variables, rest A and U are constant. So we are supposed to prove this. Again, let's concentrate on this only. Again, we can write this. The displacement covered by a body may be written as average velocity multiplied by time. The displacement covered by a body, as was in the previous case we have considered, average velocity is the arithmetic mean of u and v. So what we can write is S is equal to v plus u by 2 into t. I have written the same step. Now look, here we are not supposed to, we are supposed to get relationship between u and v and s. So t needs to get eliminated. So here t is to be substituted in terms of v, right? So what to do is, from this equation, v equals to u plus v minus u is equal to at, isn't it? So t can be written as v minus u divided by a. Put this as equation 1 and this as equation 2. Look, as solution is v minus u by t. So a and t, these two terms can be interchanged. So t would be equal to v minus u divided by a, right? Here we need to eliminate this t. So in place of t, you can substitute this value. So from 1 and 2, what we get is S is equal to v plus u by 2, and in place of t, you can write v minus u by a. Clear? Now, numerator, it's in the form of a plus b, a minus b. And students, you all are aware of the formula. A plus b into a minus b is a square minus b square. So, it can be written in this particular manner. V square minus u square divided by 2a. Write the reason. A plus b into a minus b is equal to a square minus b square. This is the formula which I have used over here. Now, cross multiply it. What do you get? 2as is equal to v square minus u square. So this is the third equation of motion, which is also known as velocity displacement or displacement velocity relationship. So student, these are the three equations of motion. Look, these equations of motion can also be modified for uniform motion as well. In case of uniform motion, you need to substitute the value of A as 0. In uniform motion, there is no change in velocity, so acceleration will be 0. So if you substitute A over here as 0, we get V equals to U, which is the case in uniform motion. In case over here A is 0, then distance is equal to simply speed into time. Over here as well, if A is put 0, then V would be equal to U, isn't it? So these are the three equations in which the value of A is considered to be constant. So these three equations are collectively known as the equations of motion. So we have derived the equations of motion using normal method. Now we will try to derive the same equations of motion graphically, right? So for that we need to plot a graph. We need to concentrate on plotting graph, VT graph, that is the velocity time graph, and then we will be easily able to derive all the three equations of motion. Now students, just recall the topics which we have already discussed. In case a body is in uniformly accelerated motion, then the VT graph, that is the velocity time graph of a body, is a straight line inclined towards the time axis, right? So we will try to derive the equations of motion using graphical method. So let's do it. Okay, the graph would be somewhat like this. This is the nature of the graph. This is time, it is t, right, in seconds, and this is velocity. This is velocity. This is t equals to 0, right? And suppose this is at t equals to t. These are the two instants. And as we have already discussed earlier in intro, I have told you, between time t equals to 0 to t time has elapsed, and during this time the body has traversed a displacement of s, during which the body has changed its velocity from u to v. So we have already discussed VT graph of a body having uniformly accelerated motion is a straight line inclined towards the time axis. If the initial velocity of the body is 0, then the line would have passed through the origin. In case it possesses some non-zero finite value, then this is the initial velocity, right? So the coordinates over here are 0 and u. U is the initial velocity of the body. This is initial velocity, right? Okay, after time t, this is it. The coordinate of this point would be x coordinate, that is t, y coordinate, this is v, the final velocity. So what I mean to say is that in time t, the velocity has changed from u to v. U is the initial velocity, this one is u initial velocity, and this one is the final velocity. This one is the final velocity, which is v, right? Now what to do is, you can drop a line like this, parallel to the horizontal axis. So the entire figure can be divided into two parts. This is a triangle and this one is a rectangle. So this is u. It's a rectangle, opposite sides are equal. So out of v, this is u. So the remaining distance would be, v minus u. So I think diagram should be pretty clear. Right? This is the velocity time graph of a body having uniformly accelerated motion. Again I repeat, VT graph is a straight line inclined towards the time axis. Right? Okay, velocity time graph. We know that the slope of VT graph, velocity time graph, gives the acceleration of the body. So we need to find out the slope. So acceleration, it is equal to slope of the graph. And students, slope is, I have told you, this is x1 y1, this is x2 y2. This is suppose x1 y1 and this is suppose x2 y2. What is slope? y2 minus y1 divided by x2 minus x1. This is the y-axis and this one is the x-axis. The horizontal is the x-axis, the vertical line is the y-coordinate. So, slope will give us acceleration. So, acceleration is y2 minus y1. y2 is v, y1 is u. Right? y1 is u. x2 minus x1. x2 is t and x1 is 0. So, slope of the graph will give us acceleration. So, we get a is equal to v minus u by t. That is the time rate change in the velocity of the body, which we have already done theoretically. So, cross multiply this, we get at is equal to v minus u, or v is equal to u plus at. As I have already told, this is known as velocity time relationship. So, graphically it can be easily verified. Right? Okay, let's prove this one. I have told you two importance of velocity time graph. One is the slope of VT graph gives us acceleration. The second one is, students, the area under VT graph that gives the displacement covered by the body. So, second important point is area under VT graph. Area under VT graph that will give displacement covered by the body. Right? So, displacement is equal to area under VT graph. And our intention is to find out the displacement of the body from 0 to t time. This is t equals 0, this is t equals t. So, what we do is, we need to find out the area of the entire geometrical figure. Right? It is a trapezium. Right? So, it is actually equal to S is equal to area of trapezium. Which geometrical figure is this? It's a trapezium. These are the two parallel sides and these are the two non-parallel sides. And students, area of trapezium is equal to half sum of parallel sides multiplied by distance between them. This is the formula to be used. So let's do it. S is equal to half sum of the parallel sides. Look, these are the two parallel sides. This side is of dimension v, this side is of dimension u. So sum of the parallel sides will be v plus u. And distance between them is t. This is the perpendicular distance between them. From here to here, it's t. So what do you get? It is t. Now, as usual, as we have done previously, you can simply solve. What you do is, in place of v, from first equation of motion, you can write u plus at plus u multiplied by t. Solve it. So it will be equal to half 2u plus at multiplied by t. So on solving and opening the bracket, you will get ut plus half a t square. This is the second equation of motion, which again is easily verified using this graph and using the fact that the area under VT graph will give the displacement covered by the body. So this is how the second equation of motion can be derived. Third one, again displacement velocity relationship. Again we can make use of the same thing. Displacement of the body would be given by area under VT graph. Now here, what we can do is, we can divide it into two parts. Or as a whole only we can consider this as an entire trapezium only. So up till this, the same steps will get involved in that case as well. So what we get is S is equal to half sum of the parallel sides multiplied by the distance between them, perpendicular distance between them, right? So what we do is, here t needs to get eliminated. So substitute the value of t. Over here a and t can be interchanged, and we know that t is equal to v minus u by a, isn't it? From this, interchange a and t, so t can be written as v minus u by a. Substitute this value over here. So what do we get is v plus u, and in place of t we can write v minus u by a. So what do we get? S is equal to v plus u into v minus u would give us v square minus u square divided by 2a. On cross multiplication we get 2as is equal to v square minus u square. This is the third equation of motion, right? Now this equation, let us come back to second one. This second equation of motion can also be derived in some alternative manner as well. Here this is the correct process, but we can also consider another scenario. We can divide the entire diagram into two parts. We can do it like this as well. This is the rectangle, considered to be first, and this is the triangle, considered to be second. So displacement may also be written as area of rectangle plus area of the triangle. It is the first one, and this one is considered to be the second figure, right? In that way also you can directly get this particular result. Look, area of the rectangle, its length into breadth, so length is t and breadth is u, so you get u into t, plus area of triangle, this is the triangle, its area is half base into height, half base, that is t units, into height, this is the height, this is the triangle I am considering. So half base into height is v minus u units. Now make use of equation 1. From first equation, what do you get? V is equal to u plus at. Therefore, v minus u can be written as at. V minus u can be written as at. Therefore, what you get is S is equal to ut plus half t. In place of v minus u, you can write it as at, a into t. So we get the second equation of motion, ut plus half a t square. So that's the second equation of motion for you. So this is how, students, all the three equations of motion can be easily derived, either graphically or mathematically, as was done previously. So I hope you have understood this very important relationship, right? These all three equations are collectively known as equations of motion. So we will discuss about the applications of these equations in the next topic.